In order to graph a piecewise defined function, we need to choose several values for each domain, including the endpoints, if there is any, of each domain, whether or not that endpoint is actually included in the domain or not. Label each of these endpoints as included or not, meaning whether the point is closed if it's included or open if it's not included. Then I want you to sketch the graph of the function. Let's do some more examples. We have f of x equals x plus 1 if x is less than 0, or x squared if x is greater than or equal to 0. Again, I'm going to break this up into two colors. I think we used red and green. In each of the domains, the domain for the green function and the domain for the red function, I need to pick several values. I need to pick in the green function values that are less than 0. Do I have to include 0? I have to choose him as a choice, but then I have to make a note that he is an open circle. And then I have to pick values that are less than him. I'll go -1, -2, -3, and I'm going to put a dot, dot, dot here because I want you to remember that the values keep going. It's not an endpoint, but it will have an arrow there. On my red function, I want values that are greater than or equal to 0. So I'm going to choose 0, 1, 2, 3. Now, how am I allowed to have two zeros here in my x? Is that still a function? Well, yes, it is still a function because one of the zeros is closed. And the reason it's closed is because of the greater than or equal to symbol. And then the green one is open because it has no or equal to symbol. This is still a function. I want you to really understand that. Now when I go back in and plug in my domain, I'm plugging the green values into the first function. I'm going to plug the red x values into the second function. So when I plug -3 in, 1 plus -3 is -2. 1 plus -2 gets me -1. 1 plus -1 is 0. And finally 1 plus 0 is 1, although that's an open circle. On my red function, I'm plugging 0 in to x squared, so 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And then I'm going to plot those two functions. So to graph my green piece, I'm going to plot -3, -2, -2, -1, -1, 0, and 0, 1. But when I get to 0, 1, make sure you put a nice large open circle there so I can see right through it. And I can tell that this piece looks like a straight line. On my red function, I have 0, 0, 1, 1, 2, 4, and 3, 9. And when I connect those, I have a nice parabolic function here, although you only see part of the parabola. And this is my piecewise defined function. Is this still a function? Well, yes, even if you pass your vertical line here at 0, you're only really at one point at a time. Your green values come up here closer and closer and closer to 1, but then they hop immediately down to 0, and then they continue on. So this is still a function. It still passes the vertical line test. For the next function, we have 3 pieces to our function, so we're going to need 3 different colors. When I pick x values, I'm picking from 3 different domains. My green domain starts from -3. Now that's not an infinity, it's the endpoint is -3, and I need to pick values all the way up until 0. Although 0 is not included, or we'll call it open. The -3, though, because it's less than or equal to it, is closed. For the red function, I have the only domain is at 0, and that is closed because you're allowed to be equal to 0. And thirdly, x is greater than 0, so I'm picking all the values greater than 0, including 0. But I just make a note that that is an open circle because x is greater than 0 but not equal to it. I just need to know where to end my line. On the blue, I'd like to make a note that this does keep going on forever because there is no endpoint above 0. When I go back to my green function, I'm plugging negative 3 in to the green equation. Negative 3 plus 3 is 0. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. And 0 plus 3 is 3. For my red function, when I plug in 0, I'm getting out the value 2. And for my blue function, when I plug in the value 0, the square root of 0 is 0. The square root of 1 is 1. The square root of 2, well, the square root of 2 is some decimal, 1.4, but I really is not something I want to graph. Now, I'm the one that picked these values, right? I can just say, you know, I don't really like that value that I picked. I just started picking values greater than 0. But I don't have to use that one if I don't want to. How about the next one? The square root of 3, well, that's still not something that I know in my head, so I'm going to take that out. What is the next perfect square that I do know? I know the perfect square of 4. Square root of 4 is 2. So I have more values here, but I have, I think, enough for me to graph. On my first green piece, I'm going to plot negative 3, 0, it's a closed circle, negative 2, 1, negative 1, 2, and at 0, 3, I want an open circle. I made that nice and big just to make sure you could see that on the video. On the red piece, I have a point at 0, 2. That's a closed circle. And on my blue piece, I have an open circle at 0. Notice that this is still a function. I'm only defined at 0. My value at 0 is 2. Even though I have 2 open circles here, that's okay. I'm not really defined there. It's just an open circle endpoint for my other 2 pieces, my green piece and my blue piece. And I have 1, 1 and 4, 2. And now I have the graph of this piecewise defined f of x. Our last example has 2 pieces. All you do is green again and red again. But notice that my domain is a little bit different than before. X is not equal to 0 and x is equal to 0. So all values that are not equal to 0 are going to lie in my green piece, and the only piece that is going to be in my red is the value at 0. So for my green domain, I'm going to choose negative 2, negative 1, 0, 1, and 2. Notice that this keeps going in both directions, but I just need to grab a few. Now some students say, hey, you're not allowed to equal to 0. And you're right, I'm not. So I'm going to make a little note that says I'm open at 0 for my green piece. Whereas for my red piece, the only value I'm allowed to plug in is 0. When I plug in the absolute value of negative 2, I'm getting 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. All the way down. But for my red function, when I plug in 0, the only value I get out is 1. To plot this, I have negative 2, 2, negative 1, 1. At 0, 0, make sure that you have an open circle there. I have an open circle in the green part, but I have a closed circle for my red part. 1, 1, 2, 2, and you can see that your line kind of looks like a V shape, which we're going to talk a little bit more about next unit. For my red part, I have 0, 1. I have a nice closed circle right there at 0, 1. Is this still a function? Well, sure, it still passes the vertical line test at every single point, including 0. It's only defined at one point at 0, even though we have an open circle that's not really defined there.
Mrs. Soleil just explained how to graph piecewise functions. Now let's look at some possible real-life applications of piecewise functions. Perhaps a museum charges $5 per person for a guided tour with a group of 1 to 9 people. or a fixed fee of $50 for 10 people or more. Can you set up a function? Sure. Meaning, let's say the cost for if you had under 10 people would be $5 times however many people you had. So if you had one person, it would be $5, two people, it would be 10, 3, 15, and so forth. But once you got up to 10 people, all you would pay is $50. That would be a piecewise function. So we could write it as f of x equals to 5n, but the domain would be if n is less than 10. That means the cost for up to 9 people would you multiply however many people you have times $5. But you'd have a fixed cost of $50 if n is greater than or equal to 10. Do you happen to have a piecewise function in your life? Probably on your cell phone, maybe even your data plan. Most data plans are now limited. You pay for up to so many gigabytes, but past that you pay a lot more. So here is a piecewise defined function that says the dollars for the gigabytes of data transferred use. It says it costs you $25 if you use between 0 and 2 gigabytes, meaning if you don't even use any, you're going to pay $25 a month. But once you go over or reach 2 gigabytes and go over, you pay that much. So let's just evaluate that piecewise function. So let's find the cost of 1.5 gigabytes. So the cost of 1.5 gigabytes. Which piece do you use? Well, you would use this first one because my g value is 1.5, which is between 0 and 2. So there's really nothing to figure out. It would cost me $25. But what if I used $4? Well, now I would use the second piece because my g is over 2. So I'd have 25 plus 10 times 4 minus 2. Let's see, that's 2, so that's 20. It would cost me $45. So quite a big skip. Piecewise functions are really pretty easy. They are all around us.